Hey geometry students, welcome to the review video for chapter 10. You can find it on these pages in your book. I'll go through every problem here in the chapter review, and hopefully you find this helpful as you prepare for your test coming up very soon. So number 1 here, we're going to be using for this whole set of problems 1 through 10, we're going to be using this picture, this diagram. So it's saying to name a point, segment, line, or circle that best represents the phrase. So let's see, diameter of circle P of what's drawn in here. I would definitely say that NB or BN, that segment, would be the best choice for that, the only choice actually for that. Number 2, a chord of circle P, you could say BN, because that connects 2 points on the circle. You could also say FB, or that would be equivalently BF. And number 3, I just did number 3, I'm sorry. That was number 3, my fault. Let me erase that. I was just going straight down there. So that was number 3. Number 2 I'll put up here. So point of tangency of circle Q. We've got point D right here would be a point of tangency. It's a point where the line is tangent, and so is C. So you could say 2 choices here, C or D. Number 4, the center of the larger circle, circle P, is certainly the larger circle. So P, the center point of that circle, is P. Number 5, the radius of circle Q. It looks like they've only got one drawn in here. You could say QE. You could also say QR, because R is a point still on the circle, so I would accept a couple different answers on that one. QE or QR would work as well. So it's the center point to any point on the circle. You could even say QC. You could say QD. I think QE is probably the best one because that's the one that's actually drawn in there. So I'm going to write these other ones though, because these are also, I think, realistic possibilities, even though they're not drawn in there. It would be a radius. Number 6, common tangent. Excuse me, still getting over this sickness I've had for a little while here, but a common tangent, so a line, in other words, that both circles are tangent to, they share in common, would be this line right here. You could call it line SC, line SB, or line BC. I would take any combination of those. It's all the same line. Why don't we go with just line BC? So that would work. But again, those different combinations of letters would work as long as you have B and C, B and S, or C and S. Any of those 2 would work out. Any of those 3 choices would work out. The secant now. The secant, excuse me, is a line going through, passing through the circle instead of tangent to it. And it says the secant, it doesn't say for which one here, so line BF, that was the only line that's actually drawn in there, and that's cutting through the circle. It's not just going through 1 point, it's going through 2 points of the circle. So number 7 should be that. And number 8, the point of tangency of circle P and circle Q. Looks to me here like it is definitely the point of tangency of circle P would be B, and the point of tangency of circle Q would be C. And so I'm just going to label it like this. Circle P, it's B, and circle Q, that goes with C there. You could say C, or you could say D in this case too, because that's another point of tangency right there. Number 9 is PBC. PBC right here, is that a right angle? And explain? Well, I would say yes, because a couple of reasons. It shows us that that's perpendicular right here, so that means that would have to be perpendicular right there as well. So yes, you could say by either a linear pair or by the fact that this is a tangent point, and so there's a theorem that tells us that that would be perpendicular right there. And that theorem right here, theorem 10.2, that's coming from the first lesson in this chapter, 10.1. But theorem 10.2 says if you have this line perpendicular to a radius of the circle, then it's tangent to the circle. So we could say either one of those reasons. I could say yes by linear pair or by theorem 10.2. And then show that this is isosceles. I can go back to this right here, and there's another theorem that would help me determine that. So this one says if you have two tangents, then the segments here and here that are tangent, here and here that are tangent, are going to be congruent. So this is theorem 10.3, and that's where I want to go. There we go. So we can say for sure that this SC would be congruent to SD, by theorem 10.3. So it follows excuse me, that triangle SCD is isosceles. That's the definition of isosceles triangle, that it has at least two congruent sides, just like this triangle right here. This is the triangle in question when they're asking about that has two congruent sides based on theorem 10.3. Okay, so let's move on to next group here. So use circle Q in the diagram to find the measure of the indicated arc. It says AD is a diameter, and the measure of arc CE, so from C to E, so I'll kind of label that like this, from C to E here to here is 121 degrees. So number 11, trying to find the measure of the indicated arc. So we're trying to find the measure of arc DE. Don't forget the little measure sign in front of that. If this is 121 all the way from C to E, and this is 59, what's going to be left over? All we have to do is 121 minus 59, and that's going to be 62 degrees. And don't forget your degree marks as well, since these are measures of arcs. Okay, number 12, measure of AE. So I'm going to label stuff as I go here. This is 62 degrees. We know that now at this point. And since we know that AD is a diameter, this is going to be 180 from A to D, and 62 of that is right here. So we just need to do 180 minus 62. That gives us 118. Number 13, measure of, this is a major arc now, so we have to follow the order of the letters. Start at A, go through E, and go to C. We know it's going to be 180 from A to D, plus another 59. What's 180 plus 59? I know 180 plus 60 would be 240, so it's going to be one less than that, 239 right there. Number 14, the measure of BC. Okay, so we've got, it looks like 180 right here, because this is the diameter right here, and that's going to be a semicircle. So we just need to do 180 minus these two added together. So minus the, this is one way to do this. We could actually, since we figured this out as 239, I could do 360 minus 239. So I'm showing you a couple, or at least describing a couple different ways to do this. Since I've already started thinking of it this way, I'm going to finish it this way. So 180 minus these two added together, that'd be 80 plus 15, that'd be 95, and so we'd have 85 degrees for that one. And number 15, let's label these things now. This is 118, and this was 85 degrees. Measure of BDC. Excuse me. Ugh. I promise I'm getting better. I have to be. It's not supposed to last this long, being sick. Alright, B to D to C. So we're going the long way around, B through D over to C. We just need to take our whole circle, 360, and subtract the 85 degrees from that. And so 360 minus 90 would be 270. So it would be 275 right there. And finally, the measure of BDA, going from B through D to A, you're going to be taking 360 minus this little arc right there, 360 minus 36, which will give you your final answer of 324 degrees for that one. And so now on to 17, 18, and 19. It says that kite ABCD is inscribed in circle P. Decide whether the statement is true or false. Explain your reasoning. So 17, saying that ABC, so this angle right here, and ADC are right angles. So I would say yes, that has to be true, because that right here is a diameter, and one of our theorems said that if you have an angle that touches right where the endpoints of a diameter touch, then inscribed angle like that, it's going to be half the measure of that. So 180 from here to here on the semicircle. The arc measure is 180. That means you're going back to the angle. You divide by 2, and you've got your 90 there. Let's find specifically what theorem that is, though. And so here we are. We have a right triangle inscribed in a circle. You have this being the diameter, and it works the other way as well. If you have a diameter, that's a right angle right there. So theorem 1010 is what we can use to say that by theorem 1010. You can definitely say that ABC and ADC are right angles. Excuse me. Okay, now we're trying to say that ACD, this angle right here, ACD, is going to be half of the measure of AED right here. And so how can we prove that? So this angle right here. One thing we do know about kites, I can actually erase this, and I know that kites where the diagonals intersect, like you see here and here, this actually has to be 90 degrees. This would also have to be true, that this and this would be congruent to one another in a kite. And so I actually wanted to say for number 17 that this was true by theorem. So we're trying to decide if it's true or false. I was looking at that and saying that seems like it's a false piece of information to me, because I know that the arc, going from this arc back to the angle, I should be taking this and dividing by 2. And I also know that the central angle right here, this one, is supposed to match up with this arc right here, with arc AD. So this is going to be false. And explain your reasoning. It should say something like this. That the measure of ACD, that would have to equal 1/2 the measure times the measure of this angle, not this angle. That's not going to be a right relationship. So APD. If it said that, then I would say true, but it doesn't say that. It's saying that this is half of a 90-degree angle, so that is not going to work out right there. And the measure of DAB now, so here's DAB plus the measure of BCD is supposed to be 180. Well, that's got to be true because these are, or this is an inscribed quadrilateral, and so we look at our theorems from 10.3. Sorry, got the wrong one there. There it is, theorem 10.3, lesson 10.3. This is theorem 1011. It says if you have an inscribed quadrilateral, the opposite angles are supplementary to one another. That's exactly what we have going on here. And so I can say that this is going to be true by theorem 1011. Simple as that. I can leave it right there and call that good. So 17, 18, 19, what you see there should work out just fine. Okay, now we're actually going to compute some values here with 20 through 23. And if you remember the times 2 and divide by 2 idea, that's going to help us out with this first one at least. So this angle going from this arc, saying that from B to A is 136. So we're going to be taking this, we're going back to there, we're dividing by 2. So the measure of this one should be 136 divided by 2. Half of 140 is 70, so half of 136 would be 68. So that's that one. That's not what x is though. So from there we could say this is number 20. We could say that x is going to equal 180 minus that one, minus 68. So this is what I saw as the easiest way to do this one. This is going to be what x is. Since the degree mark is after the variable, we could technically, or we technically would leave that out, but I would take that either way. So right here though, now we've got, where we're using that theorem where it's half, x is going to be, this is 21, x is going to be half of the big arc that it intersects or intercepts minus the small arc. So x is half of 170 minus 60. And that would be half of 110, which would equal 55. And again, I should technically leave the degrees out, but I'd take it either way because it's x is the number in front of the degree mark. So 55. This one, this was where we add them and we take the average of those two. That's what we see here. So x is going to be 1/2 of 46 plus 82 in this case, and that'll be 1/2 of 128, and half of 128 would be 64. And so this one we had 64 would be right here, 64 degrees. If you were asked to find this one, however, you might be asked to do something like that on the test. If you had to find that one, we'd have to do 180 minus 64 to get that one, which would make that 116. So just be careful that you read the question carefully, you look at it carefully, that you do what it asks for. And finally, the measure of this arc is something we'll need to be able to calculate this one. So the measure of LQN would equal 360 minus 86, some preliminary work necessary for this one. That would be 274 degrees. So on this one, there's the big arc, 274, minus the small arc, 86. It's still this same sort of idea. X is going to be half of the big arc minus the small arc. So this would be 1/2 of, what is 274 minus 86? Would be 188. And then half of 180 is 90, so this would be 94 for that one. X would be 94 right there. And if I look at all those, just if the picture was drawn reasonably, these should be reasonable looking answers. I would say these appear to be drawn to scale pretty well. So this seems reasonable, 55 degrees for that angle. This seems fairly reasonable right there, that could be 64 degrees, and 94, just a little bigger than a right angle. Seems legit. Okay, so let's move on to the next batch of questions here. For 24, there was a theorem that told us we could just multiply the pieces of the segments together and set them equal to one another, the pieces of the chords. The 16 times x would equal 10 times 8. This one would become 16x equals 80 then. If you divide by 16, you get x equals 5. For 25, when we have ones like this, it becomes a little more tricky. You have the outside part times the whole thing. So you would have 10 times 10 plus x there. And then here we'd have 12 times 12 plus 25 on that one. And so here we'd have to distribute that 10. We'd have 100 plus 10x. And here we could add these two together first. So 12 times 37. 12 times 37, I'm going to get out the calculator for this one. 12 times 37 is going to be 444. And so now if we subtract 100 and then divide both sides by 10, this one will leave us with a decimal of 34.4. I'm just moving the decimal one spot since we're dividing it by 10 here. And now for number 26. Same idea as here, but with one little twist. It's the outside part times the whole thing. So x times x plus 30 is going to equal this part times itself. So 20 squared. Distribute that x, you'd have x squared plus 30x. And x, there we go. This side would equal 400. So if we subtract 400 from both sides, that leaves us with this. And so your first plan of attack should always be to see, well, can I factor this? If you can't factor it, or if you just can't figure out how to factor it, you can always fall back on the negative b plus or minus the square root of b squared minus 4ac over 2a. The quadratic formula would also work. But I noticed on this one that I could factor it. I could split this apart into 40 and negative 10, because if I multiplied 40 times negative 10, I'd have negative 400. But if I added the inside and outside pieces, that would be 40x, and a minus 10x would combine together to give me 30x. So if I FOIL that back out, it gives me what I see there. And so this one would have a solution, because whatever you have here, if it equaled 0 altogether, x plus 40, if that part was 0, 0 times whatever's inside here is still going to be 0. And the same thing, same idea here. If you have this whole part, the x minus 10 part, equal to 0, 0 times whatever x plus 40 is, doesn't matter. 0 times anything is still 0. And so what would make this one equal to 0, this binomial piece, it would be negative 40. This one, it would be 10. Now which one do we use though? We're talking about a distance here, so this can't be negative 40. That doesn't make any sense. There's no negative length, so we can cross that one out, and this becomes our answer right there. So we can say that x equals 10. And just to show you that the quadratic formula would work too, in case you're like, I wasn't following that at all, you may be having to do something like this on the test. So let's just see how that works here. So if I label those with A, B, and C and plug those things in, I'd have negative 30 plus or minus square root of 30 squared minus 4 times 1 times negative 400 all over 2 times 1. This would simplify to, we'd have 900 plus 20 or plus 1600 over 2, which would become negative 30 plus or minus the square root of 2500. That happens to be a perfect square. That's just 50. And so you have two options. You can take negative 30 plus 50. That would give you positive 20 over 2. Or you could take negative 30 minus 50. That would give you negative 80 over 2. And when you look at that, that's 10 or negative 40. And again, we don't use the negative 40. We would use 10 right there for the same reasons we had over here. So if you didn't remember how to factor, you could still fall back on that quadratic formula and do that way. Now we're moving to lesson 10.6 stuff. Depending on the year you're looking at this, I may or may not have gotten to this lesson, and so these might not be ones you have to do. They might be ones you have to do. I'm not saying for sure what that is, but if this was assigned, feel free to use these to help you get the right answer. So for any equation, we have this x minus h squared plus y minus k squared equals r squared. That's the general formula. So we're just using this and plugging some numbers in here. So this is going to be x minus, and your h and k is just the center values. The h goes with the x, it's the x coordinate of the center. The k goes with the y. So I have the same thing here and here. I've got the same thing here and here. So in this one I've got x minus 2 squared plus y minus 5 squared would equal 9 squared. And so that one I can simplify one more step. I'm going to leave this like it is, but the 9 squared would become 81. And so I'm going to draw just a really rough graph of this, but the center would be HK, so 2, 5. And the radius is going to be 9. So we got 1, 2, 3, 4, 5. So here's the center point, 2, 5. We'd have to go down 9. So this is already 5, so I'm going to go 1, 2, 3, 4 more. I'd have another point right there. We've gone 2 here, so I've got to go 7 in this direction. 1, 2, 3, 4, 5, 6, 7. I'd have another point right there. That would make the radius 9 in this direction. Then I got to go 9 more up here. I'm trying to keep the scale the same as best I can while still drawing it freehand. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. It would have to go up to there, and I've got to go 9 in this direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so right there would be my circle. Good to use a compass for something like this, but we're just getting the idea here. So I am not drawing this perfectly to scale, but that's the idea. This point is centered at 2, 5. Next up, we've got number 28 here has x minus, and we have to plug in the -4 as my h value. So it's the formula has x minus whatever that h value is. If the h value is negative, you got to plug in that as a negative. So we have this plus y minus -1 squared would equal, the radius is 4 in this case, so 4 squared. This would become x plus 4. Anything with a minus and negative can be changed to a positive. We'd have y plus 1, and we'd have 16. So the center is at -4 and -1. The radius is 4, so this one's a little easier to draw, I think, because it doesn't go quite so far out. But -4, 1, 2, 3, 4, and -1. That's your center point right there. And the radius is -1. There we go. The radius is 4, and so we're going 4 from each direction from that point. So 1, 2, 3, 4 gets you right on the y-axis there. We already went down 1, so we got to go up 1, 2, 3 more. There's another point. We'd have to go 4 out in this direction. 1, 2, 3, 4. There's another point, and 1, 2, 3, 4 is another point right there. So we've got a circle right there, centered at that point right there. And finally, 29. Let's plug in the numbers again. We've got x minus a -6 and y minus 0 would be the square root of 10 squared. Nice thing about that is the square root and the square will cancel. And here you'd have x plus 6 squared. This would just become, you just write it as y squared equals 10. And so the radius being the square root of 10, that's a little bit bigger than 3, because the square root of 9 is 3. So the square root of 10, just a little more than that. And we have a center point at -6, 0. So we go over 1, 2, 3, 4, 5, 6. Get a point right there. And you're going just a little more than 3 in each direction. 1, 2, 3. I'll go that way. 1, 2, 3. And 1, 2, 3. So it's going to be just a skosh over that way. 1, 2, 3. Just a skosh over that way. And same thing here. Just a little bit higher. And just a little bit lower right there. So we'd have our graph looking similar to what you see there. This point right here is at -6, 0. And so that'll do it for this video. There are some problems from 10.7. I am highly, I'm probably not, let me just put it this way, I'm probably not going to assign problems from that one. So if I do assign those in a later year, though, I will make up a separate video where I just go through those ones on a separate shorter video here. But 1 through 29, this is stuff that you may see on the test. It just depends on what lessons have been assigned for this chapter. It might just be the first 5, it might just be the first 6, it might be something else other than that. Just check with me in class and see what was actually assigned. But if you notice any mistakes in here, or you have any questions, come talk to me before or after school or during class, and I'm happy to help you out. Let's make sure we study this stuff and study it well, and so we know what we're doing and get ready for that test coming up soon. Alright, I'll see you guys later, and hope you have a good rest of your day.